away. So we've talked about the standard normal curve. That's a z variable. And let me write it like this. It is distributed normally with a mean of 0 and a standard deviation of 1. That was our standard normal curve. Standard normal curve. And there's only one standard normal curve. The rest of them are normal curves, but they're not the standard normal curve. So if it's not exactly this, then you can have x is distributed normally with a mean of mu and a standard deviation of sigma. So what this notation is shorthand for is what I just said. X is distributed normally with a mean equal to mu and standard deviation equal to sigma. That's exactly what this is saying. And it's convenient. It's really nice and convenient because it takes the place of a lot of verbiage there. So you're going to see me use this a lot. It's not something that the author uses, but that's fine. Now, why would we consider other normal curves? Well, that's a good question. Let me show you one answer. And let's see. Yeah, here it is. So we've got the average height of something here in inches, and it's shown as a histogram. But if you look at it carefully, what you can see is that even though it's shown as a histogram, whoops, I want to back up a slide. Even though it's shown as a histogram, a normal curve with the right parameters, the right mean and standard deviation, seems to approximate that pretty well. And there's a lot of phenomenon that can be modeled with a normal curve. So that's why we're moving to this non-standard normal curve. So let's see. So this is an example of a normal curve with a mean of 100 and a standard deviation of 15. But what I want to show you is that you can play with these parameters. You can change the mean, you can change the standard deviation, and let's see what effect it has on our graph. Now, currently, the center of this graph is 100. That's what the mean is. But we can change that. We can change its shape in a couple different ways. You can change its location by changing the mean, and you can change its shape by changing the standard deviation. So let's start by changing the mean here. It's at 100, and just move it around. You'll see another graph slip out from behind the blue graph. And okay, so that's what changing the mean does. You're just shifting it. Now, before I change the standard deviation, remind me what the standard deviation talks about. What does the standard deviation say or tell us about some data?
How much the mean deviate, or how much the data deviates from the mean?
Perfect. How much the data is spread out or deviates from the mean. Now, in this case, right now, the settings you got probably set it at a equals 8.2. What if I increase that? What if I increase that spread? Well, then I get something like this. And what's happening to the curve?
It changes the type.
Yeah, it's changing the shape, right? It's more spread out here. Now, if you dial it back down, the smaller the standard deviation gets, the more concentrated it gets near the mean. There's less spread, there's less variability. So in association with this pandemic, you've probably often heard you want to flatten the curve. And that's because what we want to try and prevent is a big spike of people going into the hospital at the same time. So if you can flatten that curve, spread out the peak, then you're going to create a situation where the hospitals can actually handle the influx of patients that they need to, unlike a real sharp spike. And that could be a disaster for a lot of people. In any case, spreading this out or changing the standard deviation changes the shape, and changing the mean changes the location. So those are the two things we can vary there. Now, our job is going to be to try and find areas underneath these curves. So, for instance, let me get back here. I could ask you for the standard normal curve. This is problem number 5, I think, in our book. They tell you that x is distributed normally with a mean of 100 and a standard deviation of 15. I could ask you to find the probability of getting a variable less than 118 for this distribution. Let me draw this first. So that. So 118, yeah, probably around here someplace. This is going to be 100. That should always be your mean here. So 118 has to be to the right of that. What we want to find is the area to the left of this. And I'll discuss 2 different ways you can do this. So, to find the area to the left of this point, we can use Google Sheets. There's actually a lot of things you can use. But we spent a lot of time with Google Sheets, so we'll continue to do so. I'll also show you how to do this on the graphing calculator. And let's see. For Google Sheets, the command is going to be pretty much the same as it was last time. Remember, the command is norm distribution of x, and then the mean, and then a standard deviation, and finally true. That's the basic command that you're going to use in Google Sheets. And that's going to give you the area to the left of x with a mean of mu and a standard deviation of sigma for, you know, that particular normal curve. So what we want in our case, say again?
We can't see that.
Oh, really? Oh, wow.
No,
Wow.
now we can. Now we can. There's just like some chat thing in the way.
Oh, okay.
We couldn't
Sorry
see
about that.
equation.
I didn't realize that. I didn't even know you could see that chat thing.
Professor Parent, where did the 118 come from?
Oh, that's given to you in problem number 5.
Okay.
So I can open up the book here. Maybe I should do that, and we can look at it there. But what we want to try and find is this probability. Now, for us in this case, it would be norm distribution of 118, which is your x. Mean is 100. Standard deviation is 15, and then true. So let me pop over to Google Sheets and see what that gives me. So you can see my command here, norm distribution, 118, comma 100, comma 15, and then true. So it should give you about 88.49. And in a little bit, I'll discuss why habitually I'm going to round my z values here, or my probabilities, to 4 decimal places. But for now, we'll just round it to 0.8849. Well, let me also show you how to do this on the graphing calculator, if you're a fan of the graphing calculator instead. So we're going to go to distributions. So second, and then distribution. You want the normal CDF. In this class, you will not use the normal PDF. So we want the normal CDF. So I'll choose number 2. The lower limit, that's the left-hand endpoint. This is your calculator's approximation of negative infinity. And we want to go all the way up to 118. Mean of 100, standard deviation of 15, and then paste and enter. So you get the exact same thing either way. And it's just a matter of what you find most comfortable. I'm happy with you using either one. What I don't want is for you to have to use the tables. It's kind of old school, and we'll show you an example of that in just a minute. But are you comfortable getting this value one way or another?
Yeah.
Yes.
Thank you. Yes. Good. Good to hear. Thank you. So let's try problem number 6. And problem 6 has got a little subtle difference. Now we're going to deal with the same mean and standard deviation. So mean of 100 and standard deviation of 15. But this time we want the area to the right of 91. So let me draw our distribution first. And I'd like to take note of the important things here that we know. X is distributed normally with a mean of 100 and a standard deviation of 15. And doing this can help me out a little bit. So what number should I put here?
Wouldn't
that be
100?
Yeah, that's 100. So where does the 99 go? To the right or to the left of 100?
To the left.
To the left. Good. So I'll put that here, 91. And the problem is asking us for this area, the area to the right of 91. So something like that. Now, by drawing this much, you can tell me something about this probability. This probability has to be at least how much? At least what?
1/2.
At least 1/2. Perfect. Because half of your data is going to lie on either side of the mean. And since we've got more than that, this number has to be greater than 1/2. Now that's important because we want to make sure that we don't forget something when we're all done with this problem. And I'll show you what I mean here. We've got to think carefully about how Google Sheets works. Google Sheets is going to give you the area to the left of something. So it's going to give me the area to the left of 91, but that's not the answer that I want. So,
Would
I
you
can
do
look
the-
up the blue area, but I need a little bit more. Is there a suggestion as to how we could get the orange area?
Do you do norm?
1 minus that area.
Say again?
1 minus that area.
Ah, brilliant. The total area here is 1. So this part is going to be 1 minus the blue part. So perfect. Yeah, we're going to use the fact that the total area is 1 and do some subtraction. So that's going to equal 1 minus norm distribution of 91, comma 100, comma 15, comma true. And let's see what that gives us. Bam, there you go. So about 0.7257. Now the reason I wanted to point out that you expect a number greater than 1 is because it's easy to forget sometimes that you have to subtract in order to get that probability. And if you forgot, if you just typed in, that's not what I want. All right. If you just typed in norm distribution, I forgot to type in the equals to. Norm distribution 91, comma 100, comma 15, comma true. The answer that you see, you should go, wait a minute, that's not right. I expected something more than 1/2. So, you know, at the very least, it gives you a way to check your answers and see that something makes sense or doesn't. So I encourage you to draw these pictures and at least get a sense of the kind of answer that you're going to get. So now, if you're doing it on the graphing calculator, well, then you're going to have to be a little bit more clever. Let's take a look at that. So again, I want to do norm CDF. So let's see here. Second distribution, norm CDF. My lower bound is going to be 91. My upper bound is really, I don't know, infinity. Now you don't have to be as crazy as a calculator and type in 1e negative 99 or something like that. I'm just going to type in, say, 1,000,000. And that should be pretty good. That should definitely get us what we need. You just want to choose a number that's ridiculously high. And there you go. We get exactly the same thing that we got out of Google Sheets, 0.7257.
I just typed in 1 minus, like how you did in Google Sheets, and it worked too.
Okay. You mean 1 minus with the normal CDF?
Yeah.
Okay, then you probably had like negative 1 E99
Right.
and then 91. Sure, that works great. Yeah, that's nice that you can do that kind of mental gymnastics to do it that way. Good job. Good job. All right, so how are we doing on those? Doing okay? Let's try a couple more here from this part of the homework. So try problems number 7 and 8. So we'll do those in order. Let me get back to our page here. Right here. Nope. How about right here? There we go. And let's move up a little bit. So in problem 7, we want to find the area between 79 and 133. Now, unfortunately for us in this problem, we can't kind of estimate, gee, it should be more than 1/2, gee, it should be less than 1/2. But when you can do that, it is a good thing to do. So let me draw our distribution here real quick, and then we'll see about trying to find its probability. So here we go like this. And what was it, 79 and 131? Are those the numbers?
Yes. No, 133.
133.
133, thank you. And we've got X here, which is distributed normally with a mean of 100 and a standard deviation of 15. That puts the 100 there. So, wow, how are we gonna do this one? Because now we got areas on both ends that we don't want to trim off. How are we gonna find this probability?
Would you do them individually and then like subtract?
Perfect. So in Google Sheets, we're going to do it individually. I'm going to find the area to the left of 133 and then subtract off the area to the left of 79. So it's going to be norm distribution of 79, 100, 15, true minus norm distribution. Actually, you know what? That's backwards. I should have the 133 here. This one minus this one. 133. Now the 79, 100, 15, true. I'll tell you what. I'll type it in backwards, and you tell me why I should know something's wrong, okay? So that's kind of a nice little mistake here, a teachable moment, as they say. So let's look here for Problem 7. Now I'm just going to change this to 79 and 133. So I'm typing it in backwards. How come my results should be screaming out at me that there's a problem?
That there's a negative?
Yeah, negative.
Yeah, there's a negative. Keep in mind that overall, this is a probability. What are probabilities between?
0 and
0
1.
and 1.
0 and 1. Awesome. So, yeah, you know there's a mistake there. At least I hope you would know that there's a mistake. Be critical of your answers. A lot of times I get answers from people that should be saying to them, well, wait a minute, there's something wrong. And I hope that that's you that's going to catch those kind of things. So 0.9053. Now, in this particular problem, it's actually really easy to do this on the graphing calculator. Kind of like it on the graphing calculator because you can type in the upper and lower limits exactly. You don't have to play around with some crazy version of infinity or anything like that. So, as before, second distribution, normal CDF. The lower is 79. Let's try that again. 79. The upper was 133. Mean and standard deviation are the same, so bam. So in that particular case, it works out really nice on the graphing calculator. And in general, it's going to be kind of up to you what you find most convenient. So let me just write down on the TI-84, it'd be this command, normal CDF. '79, 133, 115. Cool. All right. Are you okay with that one? 'Cause
Yes.
I want to give you one to try. So I'd like us to try problem number 8. And let's flip back and see what that is. So it's right here. This time we want the area between 112 and 124. So let's draw that. So somewhere in here, between our 112 and 124, this is 100. Yeah, mean of 100. Yeah, and a standard deviation of 15. Can anyone tell me something about this probability before we do any calculations?
It's going to be less than 1/2.
Perfect. This area lies completely on one side of the mean. So it has to be less than 1/2, period. So if you make a mistake somehow, maybe instead of subtracting these two things, you add them, you probably get a number that might even be bigger than 1. But it'll certainly be bigger than 1/2. And at that point, you're going, wait a minute, there's something wrong. So just kind of keep that in mind to try and catch some of these mistakes. Don't just think that everything that comes out of a computer is correct, right? There's a little thinking that goes into what you input into the computer. All right, so see if you can't find that probability. Give you a couple seconds to work on that. Okay, so the commands to do this one would look like this. Normal CDF, excuse me, how about norm distribution, I should say. Norm distribution of 118, comma 100, comma 15, comma true, minus norm distribution of, actually, you know what? I wrote the wrong number here, didn't I? This should be 124.
Yeah.
There you go. Norm distribution of 112, comma 100, comma 15, comma true. What'd you guys get for that one?
Point
You're a close one.
1571.
Is there a consensus on that one?
Yeah, I got the same thing.
Yes.
Okay,
Me too.
cool. Great minds think alike. Beautiful. So are you comfortable with this so far?
Yeah.
Yes.
All right. You need me to do this on the TI-84? Or are we good there?
I'm good.
Did it on the calculator and it was easy enough.
Okay, all right. Yeah, the between the two numbers is the easiest one to do on the calculator. All right, let's swing over to problem number 22. And this is going to kind of transition into the next set of problems. By the way, let me show you just what it's like doing this kind of old school. So let's see here. Yeah, this is from a class of mine a few years ago, back before I was really as invested in Google Sheets as I am now. And this is what you used to have to do.
We need to look up a couple values from our Z table.
So the first thing you would do is you'd take and do a transformation from your normal curve to the standard normal curve. And that transformation was that you'd have to calculate a Z-score. So that you calculate the Z-scores for both of these. One of them I rounded to 0.08, the other one I rounded to 5.08. And both of these are values that you look up on the table. Now your tables only go down to the nearest hundredth. So that's why you'd have to round things to the nearest hundredth. And then you'd have to look it up in the tables. So
So anything 3.5 and up, we're going to use kind of the generic 0.9999. So it's not quite 1, but we'll just use 0.9999 out of a convenience. So 0.9999. And then we want to find the area to the left of 0.08. So 0.0 is right here. 0.08, we'll scroll across and get 0.539 or 5319.
So, wow, that's a lot of extra work that you have to do it kind of old school, to do it with the Z distribution and the tables. Now, you're free to do it that way, but, you know, if you're doing it that way, your friends are going to be, you know, out there enjoying themselves while you're still taking the test, because this is a lot of work. And the other thing is that, you know, it's prone to errors. Okay, you can accidentally grab the wrong value. You can make an error in your calculations. There's a lot of mistakes that you can make. So it's up to you how you do this. I really don't encourage using the tables at all. I talked to the author one time, and his candid assessment of why they still put the tables in there is, oh, well, they use the book in third world countries, and there's a few professors that are kind of old school still. So, all right, take it what it's worth. I don't suggest that you use the tables. You can if you want to. Let's work with some different data though. Different mean and different standard deviation. So we'll switch over to problem 22 on page 251. I think that's towards the bottom. There we go. Now, this requires that we use this normal distribution with a mean of 68.6 and a standard deviation of 2.8. So, okay, got a new distribution. We'll write that down. And then we'll answer the questions in problem 22. Find the percentage of men meeting the height requirement. So that's between 64 inches and 77 inches. All right. .68.6 and standard deviation of 2.8. So I want to find the area between these 2 points. Old school would mean you need to transform this to a Z distribution and then look up the values from the Z table. Let's try it new school. And since I did the last one with Google Sheets,
question.
Yes,
How did you get the 68.6 and 2.8?
good question. That was highlighted at the top of the problem, right here. They gave that to you.
Oh, okay.
So it's a good question. This is not something you're supposed to inherently know by taking this class or this test. So yeah, good question. That kind of stuff has to be given to you. So let me move back here then. So we're going to do this one on the calculator. So on our TI-84, it's going to look like this. Normal, CDF. You will not use PDF in this course. And then we want what? 74, no, 68, 64, and then 77. And then the mean of 68.6 and a standard deviation of 2.8. Let's see what we get when we plug that in. So clear you out again. .64, 77, 68.6, and 2.8. All right, so 0.9484. Those of you doing it with Google Sheets, are you able to get that same value?
Yeah.
Yeah, yeah.
Okay, thank you, thank you. So there's a part B here that is going to ask us to think a little bit beyond what we've done here. So what we've done in these first 6 or so problems has been to find the area underneath a curve. But part B here is going to ask us to kind of go backwards a little bit. So let's take a look at that. It says in the Air Force, height requirements are changed to exclude only the tallest 2.5% of men and the shortest 2.5% of men. What are the new height requirements? So, okay, well, that's a little bit of a different problem here. So let me sketch that out for us here. And what we're going to try and do is we're going to try and find these points. The point that puts 2.5% of the area in the right tail, and the point that puts 2.5% of the area in the left tail. Now we're still working with the same distribution. So X is distributed normally with a mean of 68.6 and a standard deviation of 2.8. Wow, well, we can't use our normal command that we've been using. So there's 2 different commands that you can look at on Sheets. The command we need is norm inverse. And then you want to type in the percent area to the left as a decimal. So if it's 10%, type in a 0.10. If it's 30%, type in 0.30, etc. and then the mean, and then the standard deviation. So that's the command that you would do there. On the TI-84, it's going to be inverse norm. Inverse norm. Again, the area, percent area as a decimal. The mean is standard deviation. So those are the commands, and I give you these commands on your exams. But there still is a little bit of thinking that's involved in here. So let's take a look here, 68.6. We'll start out with this one. The area that we want, or excuse me, the area that we know is 2.5% of the area to the left. So, okay, that'll equal norm inverse of 0.025, the mean, and standard deviation, like that. And let's see what that gives us. No, wrong one. How about over here? So there you go. About 63.1 inches.
Yeah, that's what I got.
Cool. How about my graphing calculator crew? Are we getting the same thing?
Yes.
Wonderful, wonderful. Well, we have to think a little bit more when we're working on the second part of it. So we've got 63.1. That makes sense because it's to the left of 68.6. And now I'm expecting something to the right of 68.6. But what command am I going to type in here? How am I going to get the point that has 2.5% of the area in the right tail? That's not exactly how this command works.
Would you do 0.975?
Ah, beautiful. So for the second part, when you take 100% minus 2.5% equals 97.5%, or as a decimal, 0.975. So that's the area to the left. And so if you got 2.5% in the right tail, 97.5% of the area is in the left tail. So well done. Norm inverse of 0.975, comma 68.6 and 2.8. And let's see how we did on that one. You should be getting about 74 something, I think. So you're getting about 74.1?
Yes.
Nice.
So where's the 97.5? Like what area is that? Is that the left or the right?
That's the area to the left of this point. So let me show up the graph again. So if 2.5% of the area is in the right tail, then the rest of it, so 100% minus 2.5%, that means 97.5% of the area is in the left tail. And then 97.5% is 0.975 as a decimal. Does that help?
Yeah.
Okay, thank you.
So would you consider like 63 is in the bottom 2.5%? Is that what you would say?
Yeah. So another way to think of this is that's P sub 0.025. That's the 2.5 percentile. Whereas this is P sub 0.975. So it's a 97.5 percentile. Separates the top 97.5% from the bottom 2.5%. Top 2.5% from the bottom 97.5%. Now, confusingly, it's also known by a z-value, or, yeah, it's not quite a z-value, but yeah, if this was a standard normal curve, we could write z sub 0.025, but I'll save that for when we work with the standard normal curve again. All right, are we okay with these areas here? That's the big thing for your for this section, is to be able to get into and out of these different areas. Should we do one more? Sure. All right. Let's just jump up to problem number 21 then. So we'll stick right here on this page and see what we can do for problem number 21. I'll give you a couple minutes to work on this on your own. So keep in mind that you're dealing with a different distribution. The distribution here has a mean of 63.7 and a standard deviation of 2.9. So that's the distribution you should be using. And this is much like the last one.
This
Which
is
problem are we working on?
Yeah. which problem?
21.
Okay.
All right.
I have a
So
quick question though about
Yeah, go ahead.
22. With 22B, so it's asking for like what are the new height requirements? Would we say that would we round up from 63.1 and make it it'd be 64? Since
no, good question. I would round to the nearest 10th, because I can't imagine somebody taking out a ruler and measuring to the nearest 100th. Your height would change by more than that naturally during the day. You start out tallest in the morning, and then you just shrink towards evening. So if you want to look good for your physical, get in the morning. That's when you'll be your tallest. So,
Okay, I was just thinking that because of the significant height,
yeah,
I get it though.
I just rounded to the nearest 10th. I guess if we're really being strict and following the author's guidelines, you round to one more digit that is present in your data. So that'd be to the nearest 100th if we kind of consider that we're given the average height to the nearest 10th. So yeah, I could go back and round it to the nearest 100th. I just guess I didn't see it being very practical that you round to the nearest 100th. I mean, even if you measure yourself twice in a row, I don't think you get the exact same answer to that level of accuracy. Just guessing though. Okay, let's find out how you're doing. So with the first one, here's your commands in Google Sheets. You have to subtract these two areas. Might be convenient to do that on a graphing calculator as well. What'd you get for this one? What was the approximate probability rounded up to 4 decimal places?
0.7211.
Is anyone else getting that one?
Yes.
Yeah. Yeah.
Yes. Okay, perfect, perfect. Now for the second part, we've got to use our inverse norm command. So the first one's easy because it's just the area to the left, which we want to be 0.03. So it's going to be the inverse norm of 0.03. That's our area to the left, mean is standard deviation. Let me do that on the graphing calculator and then also show you a little trick there. So let me clear out a couple things here. It's getting a little bit busy. Yes, I want to clear that. So inverse norm is off the distribution menu. So we'll go down to inverse norm, 0.03, 63.7, 2.9. Now, if you have a really up-to-date graphing calculator, it'll ask you, do you want the area to the left, to the right, and the center? That's kind of cool. We'll stick with area to the left. That's going to be a default on those of you who don't have that option on your calculator. So we get this. Now, the next command, let's see. If I want 3% in the right tail, what's that going to be? What am I going to write for my command? How am I going to get 3% in the right tail?
0.97.
Good. We'll do 0.97 is to the left, 63.7 and 2.9. So let's see what that is. Now, my shortcut for you on this one is if you hit the second key, then the enter key, it'll pull up your last calculation. And then you just go over here and change the 0.03 to 0.97. So easy enough. So about 69.2, we'll call it. Whereas the first one gave me about 58.2. Cool. Are you matching those calculations?
Yeah.
They're
Yeah.
working out for you?
Yes.
I can't emphasize it enough. Being good with the normal distribution, be able to get numbers into and out of this is really important the rest of the way. We're just going to use it a lot. So I hope and trust that you're comfortable. Make sure you do the homework problems because it's good practice, and then we'll be happy. So cool. All right. Any other questions on section 6.2 here? Looking good there? All right. Thanks.